In this video, we're going to learn how to multiply and divide surds, and then how to simplify a given surd. So first off with the rules. To multiply two surds, root A and root B, all you have to do is put them under the same root. Then when you're multiplying a surd with itself, the answer would be the number under the surd itself. So root A times root A is equal to A. Then we have root A divided by root B, which is the same as root A over root B. So if you have one of these forms, you can actually write them, you can actually combine them under the same root like that. So root A over root B is equal to root of A over B. And finally, to simplify a given surd, these are the two steps. First, you have to find the largest perfect square number that is a factor of the number under the root. Then you have to rewrite the surd as a product of the square number and another number. Then evaluate the root of the square number. All right, so let's see what happens. Anytime we see a single surd, just like root 72, we're simply gonna use these two steps. Anytime we see two surds being multiplied or being divided, like here or here, then all we have to do is use these rules first. And then once we have a single surd, we use these two steps. All right, so first off, how to find the largest perfect square number that goes into 72. Okay, so what are some of the perfect square numbers? Well, starting with 1 square, which is 1, then 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, and 10 square is 100. I believe we have a sufficient list, and we'll see if one of these numbers is the largest perfect square number that goes into 72. All right, so starting with 1, yes, 1 of course goes into every square number. So you can actually ignore the 1. You never have to actually start with 1. You can always start with this number right here, 4. So 4 does go into 72 because 4 times 18 is 72. But is 4 the largest such number? Well, we'll find out later. So 9 also goes into 72 because 9 times 8 is 72. So 4, actually, you can cross it out because 4 is not the largest square number. Okay, then over to 16. 16 doesn't go into 72, so you can ignore that. 25 doesn't go into 72. 36, well, 36 times 2 is 72. So this does go into 72 as well. And 9, well, you can scratch that now because 36 is larger than 9. Okay, now 49, 64, 81, 100, all of these numbers, of course, they don't go into 72. And it seems like 36 is the largest perfect square number that goes into 72. So we'll write root 72 using step 2. We'll rewrite root 72 as a product of 36 and 2. So it's root of 36 times root of 2. And then we simply have to evaluate the root of the square number. So root of 36 is 6. So the answer is 6 root 2. All right, let's do the second example. So root 3 times root 15. Well, clearly we can use this law right here where two surds are multiplying. So the law says that we can actually combine two surds into one. So we'll combine root 3 and root 15 into one surd, which is 3 times 15, and that is root of 45. And now because we have to simplify, we'll use these two steps. Okay, again, we're going to start finding the largest perfect square number that goes into 45 from this list, starting with 4. 4 doesn't go into 4 doesn't go into 45. 9 does, so 9 times 5 is 45. And it seems like 9 is also the largest such number because 16, 25, all these numbers, they don't go into 45. And root 45 can be written as root 9 times root 5. Okay, so from here on, this question is actually exactly like root 72, the first question. So root 9 times root 5 is now 3 root 5. Okay, and you can clearly see that 5 cannot be square rooted. There's no perfect square number that goes into 5. All right. So lastly, now root 5 times root 5 is, well, using this law, we can just say it's 5. So we'll just use a different color. So root 5 times root 5 is 5 because root a times root a is a. Then root 96 divided by root 6, it seems like it's this form, root a divided by root b. You can always convert this form into, you can combine both numbers a and b into one surd. So you can do root of 96 divided by 6, which is equal to root of 16, which is 4. All right. Now, root of 49 divided by 121, and that's root 49 over 121 is actually this form right here, root a over b. And you can simply just find out what root of 49 is, and that is 7, and root of 121 is 11. So you can actually write root of a over b into this form as well if you want. So you can do root of 49 over root of 121, which is equal to 7 over 11. But you don't have to do the intermediate step because you already know that root of 49 is 7. So you can simply write 7 here, and root of 121 is 11. But what I did here was use this rule in reverse. So if you have root of a over b, you can actually go back and say root a over root b.